Remember, I put this little minus sign on the zero when I defined the Laplace transform. And when I did this property for derivatives or transforms of derivatives, I used that same minus sign for the initial conditions. And that meant not just zero, but the limit at zero coming from the left. Not all textbooks do that. This is kind of a subtlety. But let's explore what happens. Let's look at two similar looking differential equations. Same thing on the left here, y double prime plus 2y prime plus 10y. But in the first problem, I'll have zero on the right, but this initial condition over here, on the derivative of y at time zero. And on the second one, I'll have an impulse at time t equals zero and no initial conditions. Everything starts at rest. I would get the same subsidiary equation for each of these problems, which leads to, well, you could go through it. It leads to this solution. 1/3 e to the minus t sine of 3t. That's the same solution for each of these problems, if you just follow the process. For problem 1, problem 2, here's the solution to both. And if you evaluate it at time t equals 0, you get a 0, like the initial condition on both of them. You take the derivative, you get this, and if you evaluate that at time t equals 0, you get 1. Cosine of 0 is 1, and e to the 0 is 1. You get this derivative is 1. Well, that matches that problem's initial condition, but it looks like it doesn't match this second problem's initial condition. What's going on here? We were kind of sloppy with these initial conditions. Is that just 0? Is it the limit at 0 from the left or from the right or what? If I say these are the initial conditions, same as up here, but being specific that I'm talking about the limit at time 0 from the left, then this works out because the impulse is right at time 0. So these are the initial conditions just prior to that impulse. And when we evaluate a solution like we did here, we're really looking at, when we evaluate it at t equals 0, we're really looking at it at 0, the limit from the right. So what happened there? Just prior to the impulse, the derivative was 0. Immediately after the impulse, the derivative was 1. You had a discontinuous jump in the derivative of y. Discontinuous at time 0, or right where the impulse was. And actually, anytime you have an impulse on the input, here it was at time 0, it's possible that you will get a discontinuous jump in either the function or its derivative or one of its derivatives. And it's kind of troubling when it happens right at 0 because it looks like you have a contradiction. It looks like you evaluated at time 0, you get 1, but it was supposed to be 0. And it's this subtle difference of what do you mean by the initial condition? Because the impulse happened right at time 0. So these should mean the conditions just immediately prior to that input impulse. If it's not an impulse at time 0, all this stuff doesn't matter. You can just get rid of these little negative signs, meaning the limit from the left. Anyway, that's So we resolved that, by the way, by more rigorously defining the Laplace transform, this lower limit and all these initial conditions. We will mean initial conditions at time zero, the limit from the left. And this is so we will catch an impulse that starts right at time zero. This lower limit will allow us to catch the impulse at time zero. Kind of go through this because if you get into system theory, we talk about impulse response, which is exactly an input of an impulse at time zero. So it's not just something that rarely happens or you can forget about it. If you get into system analysis, control systems, signals and systems, that kind of stuff, it's a big deal. The impulse response is a big deal in those cases. So you got to be kind of careful about that. So that zero with a little minus sign is a limit from the left that allows our integral to catch an impulse that happens at time zero. Our initial conditions mean just before that impulse. The solution you get when you evaluate it at time zero is the solution just after the impulse. It could be a discontinuity. An impulse at any time could cause a discontinuity in a function or its derivatives. That's about it. That's something that you might not be taught in a course on Laplace transform.